Okay, so the puzzle I'm going to show you is called Revisiting History. This was from the 2012 Mystery Hunt. And this puzzle, you can see it here on the screen, is a collection of photos of historical figures with a passage of text below each one. So, as Evan was saying, there's kind of 3 steps to every puzzle. Collecting data, figuring out how you're going to kind of index into that data, and figuring out what order you would put these things in. So, if you were just starting completely from scratch with this puzzle, you would probably look at these and start making a spreadsheet and identify who all the historical figures are, maybe when they lived and died, and start looking for patterns in that. So I can tell you, in working on this puzzle, one of the things that we discovered relatively early on is looking at these passages, is that all of these passages are references to the BBC show Doctor Who, specifically episodes in which Doctor Who interacted with these historical figures. Now, this is an example at the point at which you now could collect a lot of data about these simple images with these pieces of text, right? Because now we're talking about episodes of television. So there's, when did that episode air? What was the name of the episode? What was the name of the actor who played the historical figure? What was the name of the actor who played that version of the Doctor? Some of the passages reference the Doctor's companion, which companions were in that episode. So you might start building a massive spreadsheet that looks at those different things.
And when you're actually solving the puzzle, you're not going to have any idea until you really get into the solving of it, which of these pieces of information you're going to need and which are just extraneous.
So at this phase, gather everything. It's better to have some stuff and then realize there's not a pattern here, but to have that somewhat complete so that somebody else doesn't come along and be like, oh, have you looked at what the famous people's favorite colors are? I'm going to start doing that. Oh, somebody did that. They just never wrote it down. Right, start capturing things in a spreadsheet, even if you find out that it's not going to be relevant for all of the puzzles. Let's look at the actual spreadsheet we built for collecting data for that puzzle. So here is a spreadsheet that we built working on that exact puzzle. And this is pretty common. So we've got the historical figure. In the show Doctor Who, the doctors themselves have numbers, and that seemed like that might be significant, right? Maybe the number of the doctor appearing in that episode would be used to index into something. We got the name of the episode. And again, here, as Evan was talking about before, we've got spaces in here. We might need to remove those later to clean those up. Story index number, the episode number, we started making a list of companions in the episode, and then the person/people referenced in the clue that helps you find that episode. And you can see here we now have these 19 sets of data related to each image and piece of text. Now, it's always good, err on the side of collecting as much data as you can, right? So, for example, as you start collecting these, we realize that some of these episodes feature multiple doctors, right? It looks like this episode features Doctor 6 and 7. So maybe we're not going to use 6 and 7 to index into something because that would be confusing. But collect that data and then let somebody else decide that you're not going to use it for solving the puzzle rather than starting to collect it and throw it out. So you've got all your data and you've got that collected. Usually you'll have that in the first tab of your spreadsheet. It's a good idea before you start doing any kind of formulas and resortings of things, make a separate tab, paste your data in there, and start mucking with it there, because you don't want to do anything in your first tab that would kind of lose or distort patterns that might be present in the data with your manipulations. For example, sometimes the initial ordering of items in a puzzle is completely significant, and that you're intended to use that order to get toward the solution. Other times, the order is not significant and the items need to be reordered by you based on something in the data to get there. But if you had a spreadsheet that had everything in the order they're presented in the puzzle, and that was significant and you reordered it, you might therefore kind of lose that meaning, which would just kind of prevent you from getting closer to the puzzle. So you've got your data collected. The next step is to look for opportunities to index into these things. So you might use the doctor number. I might use the episode number. A lot of times when you're dealing with TV, you'll see the difference between the episode number that indicates season and episode versus story index, which is overall episode. So you look for all those, and you look for passages of text that you could index into, and look for discrepancies into that. So for example, the story index numbers get really big. It's unlikely that I'm going to be able to use the 180 to index into something unless I've got a big paragraph of text that's going to have more than 180 characters in it. The other thing to keep in mind is that order is significant. It's really easy to do the correct index into a bunch of pieces of text, but if they're not in the right order, it's just going to be gibberish, right? So, I would look for this for opportunities for what order might be significant. So it might be where these people were in history. It might be what episode they appeared in and where those episodes are chronologically. It might be which doctor is in them if there's discrete. That's another example. If there's multiple, instances of Dr. 11, I'm not going to really be able to sort by Dr. 11, right? So that information is either extraneous or means something else. So let's jump ahead a little bit. I'll tell you that this puzzle does definitely involve indexing. I think it was Sean Kane came over and pointed out, did you notice that in every little piece of text we use to identify the episode, the word who appears? That seems pretty significant when we're dealing with a puzzle related to Doctor Who. And we were like, that's right, we have not thought about that yet. It's another example of how kind of having fresh brains come over and look at a puzzle can be really useful. So we went back to our spreadsheet and we made a list of where the word who appears in it. This is counting, what word. So second word, 8th word, 7th word, and so on. This particular tab here, and again, it's a good idea to do all your kind of sorting and modifications in a different tab. I've taken the name of the episode. I've put them in the order that they appear. So this is the 4th episode up through 215th. And we're going to try indexing it into it using where the word who appears. And that, that looks good as a number to potentially index into because it doesn't get too big or too small. You've got a good, nice range here. It looks like the highest is the 20th word, and it can be as low as the 2nd word. And I've set up, just like Evan talked about, a mid formula, right? So I'm saying mid A2, so going into that, using E2, which is my index value, and 1. I want the first letter.
One thing when setting up mids that Tony is doing here that is really handy is that instead of hard coding what he is indexing into or what number he wants to take from that text string, he is soft coding them or making them formulaic. And that allows Tony to change things on the fly really quickly, which can be handy because in this case, we are indexing in based on where the word who appears in the descriptor, but we tried a whole bunch of other things first, let me tell you.
And doing it this way can also be really helpful if your data needs corrections, right? And those will come up sometimes. You'll get something and it's like, that's almost something, oh, there's a couple errors in the data. If I change this 2 to a 3, it automatically re-indexes it. If I realized I had spelled something wrong in my title, I can go in there and it would automatically re-index it. So doing it this kind of programmatic way is the way you want to do it. If you don't already know, a really common function in Excel is if you've got one little formula set up, you click and drag, and that'll apply it to everything below it, and it does it relative. So here, this cell is pulling that numbered letter out of my first cell, and so on. So I did that, and I got some gibberish. So this is a sign that probably I'm not doing it quite right. For example, it looks like the 4th letter in this particular title is a space. Usually you're never going to have a space come back to you. And what I realized in looking at this is I have not done what Evan talked about earlier. I need to clean up my data before I index into it. So I've done that. I've started my new column C here, and I'm doing it with the substitute function, just like Evan talked about. I'm taking the title cell, I'm looking for spaces, I'm replacing spaces, substituting spaces with nothing. And now I've got a nice column that is all of the names of the episodes with no spaces. And now, if we go over a little bit, I'm doing the same mid, but I'm doing it on my column without spaces. And hey, this looks like it spells out something. It looks a little weird because of where it's pulling capital letters, but we can see it spells out anagrammatic spin-off.
Spin-off.
Spin-off. The spin-off tells me there's probably something wrong in my data, and I might go over and check that. Now, omph is probably not right, and you go back and you look at your data and you realize that, oh, that was another episode. It's spin-off. if you had not already learned enough about Doctor Who at this point in the puzzle from staring at Wikipedia entries for a couple hours, you would probably ask someone or do a little bit more searching and find out that there is a spin-off of the show Doctor Who, and the spin-off is an anagram of Doctor Who. It's called Torchwood, and you would know that Torchwood is the final answer to this puzzle, and you would call that in and hopefully get a call back saying that you are correct.
You mean it's not Manic Time Flop?
It is not Manic Time Flop for this puzzle, which was at some point, and that's an example of why order is important. At some point, we were indexing into something else I don't even remember, and we got a collection of letters that looked like it could spell something. It just wasn't in the right order. Theoretically, you could use anagramming to arrive at that, but when you are anagramming more than about 8 letters, it's really easy to get something out of nothing. And at some point, we got the anagram Manic Time Flop, which seemed like it might pertain to Doctor Who, but did not. All right, that's it for revisiting history. Again, that's a really kind of simple example of collecting a lot of data, using MID to index into it in a bunch of different ways, using Substitute to clean up your data so that you can index into it properly. Next, Evan is going to talk about unfair cryptography, which is another example of a real-life mystery hunt puzzle that we solved using these types of things. That is one of the more advanced types of puzzles.